So in this second step, we are looking at really, how to solve. So generating and selecting among any alternative solutions, and going through steps like what type of a problem is it, how many ways to solve this type, and so on. So first, what type of a problem is it? So just from the description of the problem, you can see that it is a diffusion problem. It mentions that there's a diffusion process going on. Then we can also see it is given that it's a steady state problem. How many ways to solve this type of problem? How many ways? So steady state diffusion problem, that's this one, can be with reaction or without reaction. And in this case, we have no reaction because TCE is not degraded. It doesn't talk about all that. So there is no reaction. So this is the case here. So how many ways to solve this type of problem? So you notice there are really two ways that we have done to solve this kind of problem. So either a resistance analysis will work. So this is one kind, or if the resistance analysis doesn't work, then we derive things from scratch. So those are the two types of ways to solve this kind of a problem. And then the next thing we want to see is, based on the provided data, which kind of solution is most feasible. Here we have an interesting situation. We're not given a choice. We have been asked to start from governing equation and boundary conditions, so it is from scratch. From scratch means governing equation and boundary condition. So we had two choices, or we talked about two choices. Which one looks the easiest? Now, if we were given the choice of using the resistance formulation, that might have been easier because we would not have to solve the governing equation. Okay? So in another situation, we would have had two choices, and one of them, the resistance formulation, would be easier. But here we have no choice but to derive from scratch.